Hello students, welcome to our new video lecture on chemistry for class 11. In this video, we will be discussing about some basic concepts of chemistry given in rationalized syllabus of NCERT for the academic year 2023-24. The first two sections are importance of chemistry and nature of matter. To start with, I will quote Roald Hoffmann, who said, quote, "Chemistry is the science of molecules and their transformations. It is the science not so much of the 100 elements, but the infinite variety of molecules that may be built from them." Unquote. Science can be viewed as a continuing human effort to systematize knowledge for describing and understanding the nature. Some of the processes which we use in everyday life are curd formation from milk, formation of vinegar from sugarcane juice on keeping for prolonged time, and rusting of iron ore. For the sake of convenience, science is subdivided into various disciplines: chemistry, physics, biology, geology, etc. The branch of science that studies the preparation, properties, structure, and reactions of material substances is called chemistry. Let us proceed to the next slide. Development of chemistry. The branch of science that studies the preparation, properties, structure, and reactions of material substances is called chemistry. So, chemistry deals not only with the preparation of solutions and chemical reactions, but also it deals with properties, structure, and reactions of the material substances. Chemistry is also called the science of atoms and molecules, which are extensively used to describe various phenomena described in chemistry. Chemistry is not an old discipline. Chemistry was not studied for its own sake. Rather, it came up as a result of search for two interesting things. One was Paras, that is philosopher's stone, which would convert all base metals like iron, copper into gold. The second one is elixir of life, which would grant immortality. People in ancient India have contributed significantly in development of chemistry. In ancient India, chemistry was called Rasayan Shastra, Rasatantra, Raskriya or Rasvidya. It included metallurgy, medicine, manufacture of cosmetics, glass, dyes, etc. These were revealed during the systematic excavations at Mohenjo-daro in Sindh and Harappa in Punjab, which prove that the story of development of chemistry in India and the neighboring countries. Chemistry developed mainly in the form of alchemy and electrochemistry during 1300 to 1600 Christian era. Modern chemistry took shape in 18th century Europe after a few centuries of all alchemical traditions which were introduced in Europe by Arabs. Other cultures, especially the Chinese and the Indian, had their own alchemical traditions. These included much knowledge of chemical processes and techniques. Let us run through briefly about the chemistry in ancient India. Chemical processes and products used in ancient India were baked bricks, pottery, gypsum cement, lime, sand, and traces of calcium carbonate, glass in ornaments, lead, silver, gold, and copper, etc. Improvement in the field of processes, improvement the hardness of copper for making artifacts by using tin, arsenic, gunpowder, tanning of leather, etc. were were the contribution of ancient Indian chemists. The golden gloss of black polished ware, which are used in North India, could not be replicated even to this day and still a chemical mystery. Some of the places of historical importance are Mohenjo-daro and Harappa. Mosque in South India, which is famous for glass objects between 10,000 1000 to 900 BC before Christ, and Hastinapur, Taxila in North India between 1000 to 200 BCE. Glass and glazes were colored by addition of coloring agents like metal oxides. The paintings found in Ajanta and Ellora, which look fresh even after ages, testify to a high quality level of science achieved in ancient India. Books, records, and documents. Some of the books, ancient books that are that were the contribution of ancient India are Rig Veda, which explain the tanning of leather and dyeing of cotton, practiced during 1000 to 400 BCE. Rasarnavam appeared around 800 CE. It discusses the uses of various furnaces, ovens, crucible for different purposes. It describes methods by which metals could be identified by flame color. Kausalya's Arthashastra describes the production of salt from sea, copper utensils, iron, gold, silver, ornaments, and terracotta discs and painted grey pottery have been found in many archaeological sites in India. Sushruta Samhita explains the importance of alkalis. The Charaka Samhita mentions ancient Indians who knew how to prepare sulfuric acid, nitric acid, and oxides of copper, tin, and zinc. The sulfates of copper, zinc, and iron, and the carbonates of lead and iron. Rasapanishada describes the preparation of gunpowder. Tamil texts also describe the preparation of fireworks using sulfur, charcoal, saltpeter, that is potassium nitrate, mercury, camphor, etc. Varahamihirs Brihat Samhita is a sort of encyclopedia which was composed in 6th century CE. It informs about the preparation of glutinous material to be applied on walls and roofs of the houses and temples. It was prepared entirely from extracts of various plants, fruits, seeds, and barks, which were concentrated by boiling and then treated with various resins. It will be interesting to test such materials scientifically and assess them for their uses. Famous scientists and chemists are Nagarjuna. He was a reputed chemist, an alchemist and metallurgist. His work Rasaratnakar deals with the formulation of mercury compounds. He also discussed methods for extracting metals like gold, silver, tin and copper. Another scientist was Chakrapani, who discovered mercury sulfide soaps also discovery of soap also goes to him. He used mustard oil and some alkalis as ingredients for making soaps. Indians began making soaps in 18th century. Oil of aranda and seeds of mahua plant, and calcium carbonate were used for making soap. Thus, the ancient India has contributed a lot in development of chemistry. The study of chemistry is very important as its domain encompasses every sphere of life. Chemistry plays a central role in science and is often intertwined with other branches of science. The principles of chemistry are applicable in diverse areas such as weather patterns, functioning of brain and operation of a computer, production in chemical industries, manufacturing fertilizers, alkalis, acids, salts, dyes, polymers, drugs, soaps, detergents, metals, alloys, etc. etc. Chemistry contributes in a big way to the national economy. It plays an important role in meeting human needs for food, healthcare products, and other materials aimed at improving the quality of life. This is exemplified by large-scale production of variety of fertilizers, improved varieties of pesticides and insecticides. Chemistry provides methods of isolation of life-saving drugs from natural resources and makes possible synthesis of such drugs. Some of these drugs are cisplatin and Taxol, which are effective in cancer therapy. The drug AZT, that is azithromycin, is used for helping AIDS patients. In recent years, chemistry has helped in dealing with some of the pressing aspects of environmental degradation with a fair degree of success. Safer alternatives to environmentally hazardous refrigerants like CFCs, that is chlorofluorocarbons, responsible for ozone depletion in the stratosphere, have been successfully synthesized. However, many big environmental problems continue to be matters of grave concern for the chemist. One such problem is the management of greenhouse gases like methane, carbon dioxide, etc. Understanding of biochemical processes, use of enzymes for large scale production of chemicals, and synthesis of new exotic material are some of the intellectual challenges for the future generation of chemists. A developing country like India needs talented and creative chemists for accepting such challenges. To be a good chemist and to accept such challenges, one needs to understand the basic concepts of chemistry, which begin with concept of matter. Let us start with the nature of matter. Nature of matter. Anything which has mass and occupies space is called matter. For example, book, pen, pencil, water, air, all living beings, etc., are composed of matter. There are three states of matter. That is, the matter can exist in three physical states, that is, solid, liquid, and gas. Please see the figure on the right hand side, which depicts arrangement of particles in solid, liquid, and gaseous state. Solids. In solids, the particles are held very close to each other in an orderly fashion and there is not much of freedom of movement. Solids have definite volume and shape. Liquids. The liquids particles are close to each other, but they can move around. I will read once again. In liquids, the particles are close to each other, but they can move around. This is depicted in the mid position of the figure appearing on the screen. This is the liquid. So here the particles are close to each other, but they can move freely within the container. Liquids have definite volume but do not have definite shape. Liquids do not have definite shape. They take the shape of the container in which they are placed, like water and any other solution which take the shape of the container rather than its own shape. Gases. The particles are apart as compared to those present in the liquid states, and their movement is movement is easy and fast. I will read once again. Gases. In gases, the particles are far apart as compared to those present in solid or liquid states, and their movement is easy and fast. Please see the third figure here. Third container, the gases have neither definite volume nor definite shape. So gases also take the shape of its container, and there is no definite volume, and they are spread all over the container. They completely occupy the space in the container in which they are placed. Matter can also be classified into three parts: elements, compounds, or mixtures. Elements contain particles of only one type, which may be atoms or molecules. Thus, elements have only atoms or molecules. Compounds. Compounds are formed where atoms of two or more elements combine in a fixed ratio to each other. Mixtures. Mixtures occur widely, and many of the substances present around us are mixtures. These three states of matters are interconvertible by changing the conditions of temperature and pressure. So this is shown, the process is shown in the next line. That is, solid when heated becomes liquid. When liquid is heated, it becomes gas. So while heating, solid gets converted into liquid, and further heating, liquid gets converted into gas or vapor. On cooling, gas becomes first liquid, and further liquid on cooling becomes solid. On heating, a solid usually changes to a liquid, and the liquid on further heating changes to gas or vapor. In the reverse process, a gas on cooling liquefies to liquid, and liquid on further cooling freezes to solids. Classification of matter. At the macroscopic or bulk level, matter can be classified as mixture or pure substance. So matter has got two forms. It can be either be a mixture as shown in the figure on the screen, or it can be a pure substances. So there are two classifications, one mixture and the next one is pure substance. When all constituent particles of substances are same in chemical nature, it is said to be pure substance. Please see, in substance, all constituent particles are same in chemical nature. That is, it can be elements or compound. So, pure substances are elements and compounds. Whereas a mixture contains two or more substances which may be present in it in any ratio. Hence, their composition is variable. So, in mixture, different types and different ratios of particles are there. Pure substances forming mixture are called its components. Example, sugar solution, sugar solution in water, air, tea, etc. are all mixtures because there is no definite ratio. The components of mixture can be separated by using physical methods like handpicking, filtration, crystallization, distillation, etc. A mixture may be homogeneous or heterogeneous. Please see the diagram, flow diagram on the screen. So mixture can be either homogeneous mixture or a heterogeneous mixture. In homogeneous mixture, the components completely mix with each other. This means particles of component mixture are uniformly divided throughout the bulk of the mixture and its composition is uniform throughout. For example, sugar solution and air are examples of homogeneous mixture, sugar solution. Heterogeneous mixture, that is this position. The composition is not uniform throughout and sometimes different components are visible. For example, we have seen salt, sugar, grains and pulses in dry form along with some stones are the heterogeneous mixture which can be separated. Pure substances. Constituent particles of pure substances have fixed dimensions or fixed compositions. Copper, silver, gold, water and glucose are some examples of pure substances. Glucose contains carbon, hydrogen and oxygen in a fixed ratio. It is a compound. Glucose is a compound containing carbon, hydrogen and oxygen in a definite and fixed ratio and its particles are of same composition. Hence, like all other pure substances, glucose has a fixed composition. Also, its constituents, carbon, hydrogen, and oxygen, cannot be separated by simple physical methods. Elements of compounds. Pure substances can further be classified into elements and compounds. Particles of an element consist of only one type of atoms. These particles may exist as atoms or molecules. However, the atoms of different elements are different in nature. Some elements such as sodium or copper contain atoms of their constituent particles, whereas in some others the constituent particles are molecules which are formed by two or more atoms. For example, hydrogen, nitrogen and oxygen gases consist of molecules in which two atoms combine to give their respective molecules. Please see the figure shown on on the screen. Here in the upper part, atoms of different elements are shown. These are the atoms: hydrogen atom, oxygen atom, nitrogen atom, copper, atom of copper, and atom of sodium. When two or more atoms of different elements combine together in definite ratio, the molecule of compound is obtained. Moreover, the constituents of a compound cannot be separated into simpler substances by physical methods. They can be separated only by chemical methods. Example of some of the compounds like water, ammonia, carbon dioxide, sugar. The molecules of water and carbon dioxide are represented in the figure shown above. Here, water's formula is H2O. It has two atoms of hydrogen and one atom of oxygen. So, two atoms of hydrogen and oxygen are shown in the water molecule. Similarly, in the case of carbon dioxide, molecule carbon dioxide has one carbon atom and two oxygen atoms. Note that the water molecule comprises of two hydrogen atoms and one oxygen atom. Similarly, a molecule of carbon dioxide contains two oxygen atoms combined with one carbon atom. Thus, atoms of elements are present in a compound in a fixed rate and definite ratio, and this ratio is the characteristics of a particular compound. Also, the properties of compound are different from those of its constituent elements. For example, hydrogen and oxygen are gases, whereas the compound formed by air combination, that is water, is a liquid. It is interesting to note that hydrogen burns with a pop of sound and oxygen is a supporter of combustion, but water is used as a fire extinguisher. Please note down these notes, and next we will continue with some objective types of questions. Next, we will take up multiple choice questions pertaining to this chapter, that is, multiple MCQs, multiple choice questions of the Unit 1 and Chapter 1, some basic concepts of chemistry. In multiple choice questions, you will be given one question and answers are also given along with the question. You have to choose the correct answer which is applicable in the question. Let us take up the first question. Choose the correct answer. So the statement is, chemistry is the branch of science that studies the following. Your four options are: option A, preparation of material only; option B, properties of material only; option C, structure and reactions only; and option D is all the above. So four options is, we have to identify the properties and chemistry of science which pertaining to the options given. That is, preparation of material only, it deals with preparation only, or it deals with properties of material only, or it deals with the structure and reactions only, or all the options. We know after analyzing, go through all the options, the correct answer is D, and you mark it. So option D is marked with a black circle filled with black color. We will take up next question. In ancient India, chemistry was called Rasayan, Rasayan Shastra, Rastantra, or Rasvaidya, which included A. Metallurgy, medicine, manufacture of cosmetics, glass, dyes, etc. And option 4 D is all the above. So Rasayan Shastra dealt with metallurgy or medicine or manufacture of cosmetics or all the three above. So you have to examine and remember that the correct answer is it dealt with all the three options, that is metallurgy, medicine and manufacture of cosmetics. The next question is, which of the following is a chemical fertilizer? So four options are given. Option A, urea. Option B, sodium nitrate. Option C, ammonium sulfate. And the fourth option, D, is all of these. That is all of A, B and C. So you have to remember that the chemical fertilizer comprises of urea, sodium nitrate and ammonia. All these three. Hence you have to mark the correct answer as the option D. Next question. So in this question, a figure is given marked 1, 2 and 3. So a statement, the question says, choose the correct statement about 1, 2 and 3. Option A. 1 and 2 have a definite volume, but 2 does not have this property. Option B is 1, 2 and 3 are interconvertible by changing the conditions of temperature and pressure. And option 3, that is option C, is in the particles of 1, freedom of molecular movement is large. So this is 1. And option D is both A and D are correct. So among the four options, you have to identify the correct answer. That is correct statement. So you have to examine and mark it the correct answer as D. So we'll go to the next slide. Question number 5. Matter is classified as option A. Matter is mixture of salt and water. B. Mixtures and pure substances. C. Homogeneous substances. Option D is mixture of elements and compounds. So which is the correct answer? So it is confusing. You please examine and remember the correct answer and mark it. Option B is the correct answer. So matter may be classified as mixtures or a pure substances. Question number 6. Which of the following is not a pure substance? So four options are given. Option A, carbon. Option B, glucose. Option C, oxygen. And option D, sugar solution. So we have to identify the choice which is not a pure substance. We have to remember, and the correct answer is option D. Now we'll take up question number 7. In a homogeneous mixture, the compounds of a mixture are components of the mixture are option A, completely mixed with each other. Option B, are uniform throughout. The components are uniform throughout. Option C, components of mixture, none of the above A or B. And option D is both A and B. You have to remember that the homogeneous mixture completely mixes with each other or uniform throughout. So you have to mark the correct answer. The correct answer is D. Next question. Choose the correct statement from the following. So four statements are given and you have to identify the correct answer. Option A. Pure substances can be classified into elements and compounds. Option B. Particles of an element consist of only one type of atoms. Option C. The atoms of different elements are different in nature. Option D. All the above. So you read the options again and remember the correct answer and mark it. Option D is the correct answer. With this, we come to the conclusion of the Unit 1, Part 1. In the next session, we will take up Unit 1, Part 2 on some basic concepts of chemistry. In the next session, we will study about properties of matter and their measurement, as well as Section 1.4 Uncertainty in measurement. Till then, goodbye.